Okay, in order to solve this circuit, you see we have a 6 and Z6 in series, so we should simplify this and make an equivalent impedance here. 6 minus Z6, so 6 plus Z6, I write 6 plus Z6. Similarly here 8 minus Z6, I write 8 minus Z6 in together, and we have 4 minus Z4 in parallel, so I find the equivalent of this 4 minus Z4. If you find the equivalent of this, it will be 2 minus Z2. So if you have to write 2 minus Z2. So just when you solve any complex circuit like this, so I recommend you to combine these uh, impedances together to make a one impedance. So for example, here 6 minus a6, I make it like 1. 8 minus a6, I made 8 minus a6 on impedance, and 4 minus a4, I find the equivalent is 2 minus a2. So then we write mesh equations or nodal equations. Or welcome everyone. Today we will be solving a question using Thevenin theorem. So this question was, this is a standard final exam question. You have to find the Thevenin equivalent circuit from the terminal A and B, and you need to find the Thevenin voltage, also the Thevenin impedance, and you have to determine the value for load impedance should be connected to get the maximum power transferred and also the maximum amount of power. So let me see how to solve the find the Thevenin equivalent circuit. So if you can remember that what will be the Thevenin equivalent circuit, the Thevenin equivalent circuit will come up with a Thevenin voltage source and also a Thevenin impedance, and terminals A and B. You should connect a load ZL in the terminals A and B. So you need to find the equivalent voltage, Thevenin equivalent voltage, and also the Thevenin equivalent impedance. So to find the Thevenin equivalent circuit voltage, we need to remove this or make an open circuit voltage here. So you need to remove this load impedance and find the voltage over here, the open circuit voltage. So that will be the Thevenin voltage. So open the L, open the load terminals, and find the Thevenin voltage. So to find the Thevenin voltage, we can apply, let me redraw the circuit to find the Thevenin voltage. So to redraw the circuit, I open up the terminals, load terminals A and B, and find the voltage across these 6 ohms. You see the 6 ohms in parallel with the load. So if you open up this, you will get a 6 ohms here, and the voltage, the one side of 6 ohms is connected with A, other side with B. So just the voltage across negative 6 ohms will be the Thevenin voltage. So I might voltage across this is the Thevenin voltage, and we can apply mesh voltage method, mesh current method for solving this. So let us assign mesh current I1, I2, I3, and I4 here. So I1, I2, I3, and I4, and write the mesh equations. So to write the mesh equations, like say for mesh equations for mesh 1, for this mesh, you see we have 5 ampere current, and if you have a current source connected with mesh, so you know the mesh you should relate the current source with the mesh current, and we cannot write Kirchhoff's voltage law because of this current source. We have no idea what will be the voltage across this, because a current source has a fixed value for current but could be any value for voltage, so we have no idea about the voltage source. But even we cannot apply Ohm's law for a current source. That's why we will try to relate this current with the mesh volt current with this mesh current, this current source with this mesh current. So if you apply the current source here, the current value of this is 5 amperes, and the mesh currents, you see, if you take the mesh current, so this is solely connected with this mesh. So and this mesh current is I1 will be the current over here, and here will be I1 minus I4 because this is a shared component, and here the current will be I1 and I2, but here the current is entirely I1 because it is only connected with branch that is not shared with any other mesh. So the current is 5 ampere is equal to I1. So I write I1 equal to 5 angle 0. You can write it like this, or you can simply take the magnitude, because angle is 0 degree. It is not necessary to show or take 0 degrees while you enter the number on the expression or in your calculator. So you can write 5 only. By default, calculator takes 0 degrees. By default, it takes 0 degrees. So just 5 is enough for solving this question. Now I write the mesh. Now let me write the mesh equations for this mesh. And if you look at this mesh here, it is includes a current source, so we cannot write Kirchhoff's voltage law, apply Kirchhoff's voltage law here. So this is because of a current source present, so we need to take or make a super mesh here. So exclude this branch and write down a super mesh equation. So if I write a super mesh equation, you see the voltage. If we have a voltage source available or present in a branch, we don't need to take the current expression, right? Don't need to pay attention to the current, mesh current, right? Simply because we'll be writing Kirchhoff's voltage law. As voltage is given, we need to write down only this voltage here. So this voltage is 560. This voltage is 1045. So I start with the negative sign here. So write negative 1045, negative 1045. Then positive 5 minus 60. Positive 5 minus 60, exclude this branch, and 8 minus j6 times the current I3 minus I4. 8 minus j6 times the I3 minus I4. 2 minus j2 I3. 2 minus j2 I3. And also for the super mesh equation here, you see this current, we should relate this current with the mesh current. So you see this current will be flowing in this direction, and this direction is consistent with I3. So this is the same to the I3 but opposite to I2. So if you take I3 minus I2, that is equal to 1530. So you got I3 minus I2, 1530. Now write the mesh equations for this mesh. So for this mesh, you see J6, negative J6 has current I4. Then 8 minus J6 has I4 minus I3. The voltage is negative 560. And 6 plus J6 has I4 and I1. So I4 minus I1 equal to 0. Now I solve this equation. So to solve this equation, I took the expression for this expression. So I got 8 and 2, 10, I3, and 6, Z2, Z, Z8 I3. For I4 we have 8 Z6, 8 Z6 I4, and we have 1045 minus 560 negative 60. So just I simplify the expression here. And if I take this equation, so for here I3 was negative 8 minus Z6, so negative 8 minus Z6 I3. Then I4 has 8 and 6 plus Z6 and minus Z6. 8 minus Z6, 6 plus Z6 minus Z6, I4. And the current value is 560. So this is what I get from here. And also we have the current I1. I1 is 5. So I can write Z plus Z6 times 5. Z plus Z6 times 5. So I substitute I1 in this equation. Now if I further simplify this equation, so for this I will get this one, and from this I will get these equations. Now we have two unknowns, I3 and I4. So let me put this in matrix form. So if I put them in matrix form, you will get 10. So our equation is equation where 10 minus Z6, so I write 10 minus Z6 minus 8 minus Z6, so I write 8 plus Z6, I multiply with negative sign, so it is negative 8 plus Z6, negative 8 plus Z6, 14 minus Z6, and I3, I4, and the right hand side is 4.57, this 32.5 plus this. That I solve for this part, and I got this one, this value, and then I replace the first row with this value with the right hand side and keep the second row as it the second column as it is, and then I solve it. Then I found for delta 2, to delta 2 just I have to take replace the second column with the right hand side values, and I solve this. Then for I3 will be delta 1 over delta, so that gives us this, and I4 equal to delta 2 over delta, that gives us this. So now to find Thevenin basically, if you look at this expression here, Thevenin is negative Z6 times I4. So I write negative Z6 times I4. So negative Z6 and I4 is this. And the value is 34.7 or the 31.7 times this, or in polar form the value is, in polar form this value is this. So this is how this is my Thevenin voltage. We can get it using mesh analysis method. Now we need to find the Thevenin impedance. So to find Thevenin impedance, just I remove all the dependent sources. So let us start with this problem. So you see we have a current source here, so this current source must be open, and we have a voltage source here, so this will be short, this will be a short, and this will be open. So we have this branch must be open up. So this will be shorted, this will be short circuited, this will be open again. So if you see the equivalent circuit by moving this, you will get Z6, and I write 6 minus Z6. So basically I combine these two impedances, series impedance, together and make Z plus Z6. I should mention it earlier that these two branches 4 and J4, we combine this to make the equivalent impedance over here. So instead of doing a mesh equation, mesh current for this and this, just I instead of using take them a separate branch here or separate mesh here, we should combine these two and the equivalent impedance and replace this with an equivalent impedance. So now I redraw the circuit and I got negative Z6, and here 6 plus Z6, and I shorted this one, shorted this voltage source, open up this voltage source, and we have 8 minus Z6 and 4 Z4 parallel becomes 2 minus Z2. So now if you look at this this equivalent circuit, you will see that 2 minus Z2 and 6 minus 8 minus Z6, these two impedances are in parallel. So I find the equivalent impedance for these two. So the equivalent impedance 1.609 this. So we'll get Z prime equal to 1.609 and this. So if you see Z prime and Z prime, and these two will be in series, and that is in parallel with J6. So now you will see J6 in parallel with this plus this. So the 6 plus J6 and Z prime. So then I solve this and we come up with the equivalent impedance, this one. This is the equivalent impedance, and that's the Z Thevenin. So we found Z Thevenin and B Thevenin. So once you get Z Thevenin and B Thevenin, and B Thevenin, we can find the values, the numbers, right? So got B Thevenin equal to 31.7 minus J 21.918 or 38.54, negative angle negative 25.48, and Z Thevenin, if you solve it in rectangular, you'll get 4.55 and J 5.09, and this value in polar form. Then R Thevenin, that was the question signed R Thevenin. So R Thevenin is the real part of this. So this is the real part. And then you have to find the load impedance ZL that results the maximum average power. So to find the ZL will be the conjugate of Z Thevenin. So if you see the conjugate of Z Thevenin got a real part. So real part is this. The imaginary part was in capacitive, so it will be inductive. So opposite. So but equal magnitude. So just I find Z 5.09. This will be positive J 5.09. And the polar form has same argument but opposite angle. So that's the ZL. So we required the load impedance of this mass to get the maximum power transferred to the load, and the maximum power will be B Thevenin square over 4R Thevenin. So I use 4R Thevenin because the values are given in RMS. You see here the question says the voltage and current are in RMS. So if the voltage or current in given in RMS, then you have to use 4. If they are given in maximum, then it will be 8, because you know RMS is equal to Vm over root 2. So if you take RMS square, it will be Vm square over 2. So that is 4 times 2 will be 8. So that means if you solve using RMS values, you have to use 4 here, but if you take the maximum values, then it will be 8. Now Thevenin, you have to take the Thevenin, the real argument of this, that is 38.54 squared over 4, and R Thevenin is 4.51, 4.511. That we got 81.6 watts. So that's the value for PL maximum. I'll show you how we can solve this circuit using superposition method. Just for superposition method, we need to consider one source acting alone. So for first case, we have how many sources? We have, let's say we have 1, 2, 3, 4 sources working. So at first we consider this source. So if we consider this source, that will be present there, but this will be replaced by a short circuit. This will be a short circuit. This is an open circuit. So I shorted this voltage source, or this short circuit at this voltage source, open up this current source. So now we shorted this, keep this current source, and short this voltage source, and short this voltage source, and open up this current source here. So if you do this, you will find this simplified circuit, and we solve for 5 current source, 5 ampere current source acts alone. So if you see this one, so you see 5 current source, and we have J6, 6 plus J6, and these two branches in parallel. So we can consider combine these two, and if you combine these two, it will be Z prime, and Z prime is the combination of this 8.6 parallel this. And if you see the Z prime will be in series with J6. Z prime in series with J6 and in parallel with 6 plus J6. So you can find the I prime. So these two branches are in parallel, right? So the entire branches from here to here in parallel with J plus J6. So you can write 5 J plus J6. I want to find this I prime. I prime will be the total current times the opposite branch impedance over the impedance of 2 branches. Sum of the impedance of 2 branches. So 5C plus J6, 6 plus J6. This is the one branch, and other branch is J6 plus this, negative J6 plus Z prime. So you will get the I prime, the current for this. The current for this. Let me find the current for J6 because of each individual sources. So current in negative J6 for 5 degrees is this much. So now I want to show you if I want to find Thevenin voltage using nodal analysis. For nodal analysis method, you have to take a reference node. I put the reference node down here, and we have to find the non-reference node. So let me say this is a non-reference node V1, and this node voltage got voltage V2, and this is V3 and V4. So we have 1, 2, 3, 4. But here V2 is directly connected with a voltage source, and this voltage source is 1045. So V2 will be 1045. And V3 has also there is a super node here. So V3 is V2, V3 minus V3 is this. So we can find V3 equal to V2 minus 560. V3 equal to V2 minus 5, this voltage. So this V2 and V3 is already we can solve without solving any node voltage equations, because V2 is a known voltage here, and V3 also a known voltage from V2 point. So V2 and V3 we don't need to solve. We only need to solve for the unknowns V1 and V4. So 2 equations are enough for two mesh equation node equations are enough to solve this circuit. So one node equation for V1 and another node equation for V4. If you see for V1, you see we have 1, 2, 3 components, so there will be 3 terms in this V1 expression. So one is V1 minus V2 over this, V1 minus V2 over this, and another is V1 minus V4 over negative J6, V1 minus V2 over negative J6, and incoming current is negative 5. So you can get negative 5 equal to 0. And V2, you already know this, V2 is connected with the voltage source, and this voltage source has a reference point here plus this. So V2 equal to 1045, and V2 minus B3 is 560. So B3 you can solve from B2. So B3 would be 10 minus 45 minus 560 equal to B3. And for B4 you see B4 over minus B4 minus B3, 8 minus J6, and B4 over 2 minus J2, B4 minus B1 minus J6 equal to 0. So, and here B3 is B2 minus this, so you can write B3 is this. So this is my B3. So if I solve this, I'll get B1. I simplify, make it in polar form, so I get 8 minus 8.48, 45 degrees, and this is 690, 695, and this. Of this, so it will be 0.18, 45 degrees, and 0.16, negative 90 degrees, and this is times B4, 6, and then B1 plus B4 equal to this. So we got one equation like this, and then for the other equation B4, if I simplify this, you'll get B4 this. Now I make them in matrix form, so Euler's formula. Then I solve for delta is this, and for delta 1, for delta 2, and then we solve for V1 and V4. So B Thevenin will be V1 minus V4. So if you solve this V1 minus V4, you will come up with this one. That we already got using mesh and superposition method. So this is how we solve find B Thevenin using nodal analysis method. In nodal analysis method, I prefer to have the polar form, because in rectangular form the number might be very small, and it could affect our final answer, or it could we might get some so now I'll show you how to solve another example from Thevenin theorem. So this is another example from Thevenin theorem. Another example from Thevenin theorem. This is 10.62 on your textbook. So you see here we are given a voltage source, and inductance, capacitance, and dependent current source, and we need to find the voltage across 2 ohms resistor using Thevenin theorem. So the purpose of this problem is to show you how to deal with dependent source. So now at first you need to convert or transform the circuit to frequency domain. So to frequency domain, you have to write down the time domain voltage source expression. This is 20 and angle is 30. So 20, 30, and the angular frequency omega is 1 radians per second. So I write 2030 volt and 1 radian per second. So here you see the equation is given in terms of maximum value. So if someone wanted to find PL max, that will be formula will be B Thevenin squared over 8 R Thevenin. So because it is given 20, not in RMS, it is in the maximum value, so the formula will be 8 R Thevenin. Okay, that's another thing. Now I solve this in frequency domain, so it is 2 henries. Now I make it ZL equal to omega L, so I convert impedance, that will be 2 ohms, and this is in farads, so I make it in ohms, and this is also in farads, I make it in ohms. So I replace this 2 ohms, negative 4 ohms, negative 8 ohms, this one, and this. I open up this terminal and I have to find the Thevenin open circuit voltage or Thevenin voltage. We apply node equation, nodal analysis methods. I take a reference node here, and if you have a reference node, so you'll see a voltage here. Let's say this voltage is V1 and this voltage is B Thevenin. Because B Thevenin is over here, so this is the voltage across this. So now if I write V1 minus 20, this voltage is 20 angle 30 over 4 V1 minus B Thevenin over J2, and V1 minus J4 plus 3 IO. Now, and from here you'll write B Thevenin minus V1 J2, B Thevenin over negative J8, negative 3 IO equal to 0, and IO equal to the current here. So this is component current, right? So this component current will be this voltage minus this voltage over this resistance. So you see IO is flowing this direction, so this will be higher potential than this one. So you say like 20 30 minus V1 over 4, so that's IO. Now I replace this IO here and find the voltage equation, simplify this voltage equation here, and I got the expression, right? V1 equal to this in polar form, the B Thevenin is this equal to 0. So then I solve V1 equal to B Thevenin over the coefficient of V1 and the constant term over this V1, coefficient of V1, and you will get the B Thevenin expression like this. Now in the second equation I multiply the entire equation with J4. So if you multiply with J4, then it will be 4 times this, 4 times B Thevenin minus V1 minus B Thevenin minus, it will be J24 20 30 over 4 by 4 equal to 0. Now I can simplify 24 and 4, it becomes 6, and this. So get 5 Thevenin, and if I take this, so it will be 4 minus J6 V1 and this one. So V1 we already solve here, so this is B Thevenin over this. Then if you solve for B Thevenin, you will get this value. This is your B Thevenin value. So here just I didn't use Cramer's rule, I just use substitution method. I solve for V1 in terms of B Thevenin, then I replace this V1 and then find B Thevenin. Now we need to find Z Thevenin. To find Z Thevenin, just I remove the voltage source connected here, or we short circuited the voltage source, but we cannot remove this current source because this is a dependent current source. We must be there, it should be there. So to find this equivalent resistance, we have to apply a test voltage source. So let me apply a test voltage source of 1 volt, and the Thevenin impedance will be this voltage over the current delivered by this voltage source IT. So the Thevenin voltage will be Vt over IT. So let me find IT, because Vt is known on volt, and we need to find the IT. So again, I use nodal analysis method for solving this, and this voltage is known now 1 volt, and this voltage will be V1. So now, like V1 over 4, V1 over negative J6, V1 minus 1 over J2 plus 3 IO equal to 0, the node equation here. And IO will be, this voltage is 0 and this voltage is V1. So it will be 0 minus V1 over 4, or 0 minus V1 over 4, and this is IO. Now V1 over 4, J V1, V1, and I replace this IO. Then I solve for V1, and V1 is this. So once you get V1, now you apply KCL at this point. You see IT is coming and 3 IO is coming, and let's say the voltage here will be 1 minus V1 over 2. The current is going here and current is going here. So I write IT is coming, 3 IO is coming, 1 minus V1 over J2 is current going, and 1 minus J8, 1 over minus J8 current is going here. So now IT will be IO. We already found IO. IO is negative V1 over 4. So I put negative V1 over 4 and replace it to the right hand side. So keep it, put it at the right hand side. It becomes 3 V1 over 4, and 1 minus V1 over J2 negative, and this is positive 1 over positive J8. So you get IT equal to this. Now if I find the Thevenin impedance Vt over IT, the Thevenin impedance is this. So we got the Thevenin impedance here, and we already found Thevenin voltage. So you can easily come up with the Thevenin equivalent circuit. So this will be your V Thevenin, and this is your Z Thevenin, and this is your 2 ohms resistor and VO. So now we got VO. Now VO will be V Thevenin over the total impedance Z Thevenin plus 2 times 2. So that will be the VO. VO is Z Thevenin. I got 11.1099 on 53.63, and Z Thevenin is 0.957, negative 47.92 plus 2 times 2. So you can get VO. Then finally the value that you obtained here, you have to write down here. Then cosine and omega equal to 1, so 1t, and the angle you will put. So the value here is 8.12 and 168.69. So you can write 8.12 cosine omega t 168.69 degrees, this volt. So finally they are looking for the time varying voltage. So I need to write the voltage expression in terms of cosine or sine function. So the source is given is cosine, so I keep cosine function. So cosine t, and the angle is 168.69.